cost volume profit analysis. So first, let's talk about cost behavior. And so, if you recall, when we were talking in, I think, class the other day, we talked about how certain costs behave in relation to production and sales volume. Some are fixed costs, meaning that the cost doesn't change with the volume of production. Uh, Compare that with variable costs, which do change. They increase as the number of units produced are increased. And then you got a couple others as well. So managers use cost volume profit analysis to make predictions such as how many units will we sell or must we sell to break even? How much does income increase if we install a new machine to reduce labor costs? What is the change in income if selling prices decline and sales volume increase? How will income change if we change the sales mix of our products or services? And what sales volume is needed to earn a target income? All right, so again, fixed costs remain the same regardless of the volume. Now that is true within a what we call a relevant range. In other words, at some point, let's say you have a manufacturing facility and that manufacturing facility allows you to produce a maximum amount of 10,000 units, the cost of the manufacturing facilities will not change up to you producing 10,000 units. But once you have maxed out at 10,000 units and you want to produce more, you'd have to probably get a bigger, well, you'd either have to expand the manufacturing facility or look for extra space somewhere. So here it shows the relation of fixed cost and variable cost to volume. And so trying to figure out what exactly this is trying to tell me. All right, so, as variable costs go up, fixed costs are going to stay the same, but total costs go up since variable costs go up. Here, fixed costs are $32,000, so you see the light blue line. It's very, very hard to see sometimes. The pink line is the variable costs. Starts at 0 and goes up as you increase the number of units that you produce. And then, of course, your total costs are the green line. That starts at 32,000 and goes up as volume increases. And you got some other costs here that I don't really deal with, but anyway, might want to look at those. But fixed cost and variable costs are the usual costs you'll have. although you can have other types of costs, as you can see from there. All right, so you can determine cost estimates using different types of methods here, and they list 3. And so the objective here is to classify all costs as either fixed or variable. And so there's 3 methods: the scatter diagram method, the high-low method, and the regression method. The scatter diagram method simply puts dots on a graph, and you've got one axis, AXIS, that lists your costs going up the left-hand side, and at the bottom, going from left to right, is the volume in units, and you can list the number of units produced and the cost of those units during a particular period here. And so you see several dots here, and I suppose 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, you've got 12 dots, so I would have to assume that this is 12 months worth of production. Let's see what the book says. Alright, so the book says in Exhibit 18.5a, the prior 12 months costs in units are graphed. Each point reflects total costs incurred in units produced in that month. For instance, the point labeled March had units produced of 25,000 units and cost of $25,000. Okay. So you can, essentially what you can do, you see a pattern there, and you can create a line of cost behavior to reflect the relationship between cost and unit volume, and you see it kind of goes down the middle of all those dots. And so it says that this line best visually fits the points in a scattered diagram. Fitting this line demands judgment, or can be done with the spreadsheet software. The line drawn in Exhibit 15A here intersects the vertical axis at approximately $17,000. So that's the red line going up and down there in the middle of the scatter diagram, which reflects fixed costs. To compute variable cost per unit, you follow 3 steps. First, you're going to select any 2 levels of units produced from, say, 0 to 25,000. You're going to identify total costs at those production levels. So at 0 units of output, total cost would equal fixed cost of 17,000. At 25,000 units of output, total cost would equal 25,000. So what you do is, in step 3, you compute the slope of the line, which is the change in cost divided by the change in units. This is the estimated variable cost per unit. So if you take the change in cost here of 25,000 minus 17,000, your numerator is going to be 8,000, and then the change in units is going to be 25,000. And so what you have is 32 cents per unit, which is your variable cost per unit. So it says here that the cost equation that management will use to estimate costs for different unit levels is 17,000 plus 32 cents per unit. There's an easier way to do this, I guarantee, but I mean, certainly this is one way. You can use the high-low method, so let's look at that. And so you have the following relationships between the units produced and the total cost. And so using these two levels of volume, the high and the low, you're going to compute the variable cost per unit and the total fixed cost. So here, the lowest number of units is 17,500 and the highest 67,500. The corresponding costs are 18,500 and 31,000 respectively. So you're just going to run the numbers. Change in cost is 31,000 minus 18,500. And your denominator is change in units, which is 67,500 minus 17,500. So you get 12,500 divided into 50,000, which is $25 or 25 cents per unit. So step 3 is compute the total fixed cost by computing the total variable cost at either the high or low volume level and then subtracting that amount from the total cost at that volume level. So in this case, they took the high volume level of 31,000, and so at 31,000 you're producing 67,500. So the formula here, you put your total cost of 31,000 in there. Your unknown variable is fixed cost, but to that you add the variable cost that you calculated, 25 cents per unit times the 67,500, which is the high volume level here that corresponds with the $31,000 total cost. So you come up with 25 cents times 67,500 equals 16,875, and so the fixed cost is the difference between 31,000 and the 16,875, which is 14,125. And so total cost at any volume that is produced will equal fixed cost of 14,125 plus variable cost of 25 cents per unit produced. There's also something called the regression method, which is beyond the scope of this course. It's a basic course, and that's way beyond this. But you can certainly do it with a spreadsheet program such as Excel. All right, So let's talk about what a contribution margin is and what it reveals about the company's structure. All right, so you can have a contribution margin per unit as well as a contribution margin ratio here. Contribution margin per unit is simply the selling price of a unit minus its total variable cost per unit. So you see down there at the bottom, if you have a selling price of an item per unit of $100 and a variable cost per unit of $70, then your contribution margin per unit is $30. Now the contribution margin ratio would simply be the contribution margin per unit divided into the selling price. So here 30 into 100, your contribution margin ratio would be 30% in this case. All right, so from that, you can figure out your break-even point for a single product company. And so the break-even point is the sales level at which total sales equal total costs. The company neither earns a profit nor incurs a loss. It can be expressed in units or dollars of sales. There are three methods for finding the break-even point. You can certainly do it by a formula. You can certainly do it by what's called a contribution margin income statement and a cost volume profit chart as well. So as far as the formula method, you can do this in units or dollars. For units, you're going to take fixed costs as your numerator and divide it into the contribution margin per unit. Now here, in this example, we have fixed costs of $24,000. Recall that our contribution margin per unit is $30 per unit, and so it's going to take 800 units per month to break even. You can verify that by simply figuring out, and we'll show you here in a minute, how you do the contribution margin income statement. Break-even point in dollars is, numerator is still fixed cost. The denominator is contribution margin ratio of 30%. And so you're going to divide 24,000 in this case into 0.30, which is 30%, and you find that $80,000 of sales will lead to break even of $0 profit. And so here's your contribution margin income statement at break even. So this verifies that 800 units times $100 each is $80,000. So that would have to be your sales to break even. Variable costs are $70, so that's going to be a variable cost total of $56,000. That leaves you with 24,000 contribution margin. Since your fixed costs are also 24,000, you end up with zero income. So that's your break even. You could graph this as well. I'm not big into graphs, so I probably won't give you anything on it, but this is a cost volume profit chart, and this just shows you where your 800 unit sales at the bottom and your $80,000 total sales to break even merge. Anything to the right on the chart of the break-even point is where you have a profit, and anything to the left of the break-even point is where you have a loss. Now you can revise your break-even point by figuring out what you want to do as far as sales price. So that's what we're looking at here. So here you have a situation where they're taking kind of a range of selling prices for a particular product. The most likely situation is that they will sell these units at $100 each. Variable cost at that selling price would be $70. If they can sell it for $105, they believe the variable cost per unit will be $68 per unit, and fixed costs will be $21,000. And at the low end, they believe they could sell it for $95,000, or excuse me, $95 per unit. At that point, or at that level, variable cost per unit will be 72, and fixed costs will go up to 27,000. And so here you can figure out what happens if you sell for, let's say, $105 per unit. You're going to stick with your fixed costs of $24,000. Your most likely fixed cost. So that's going to be your numerator. You're going to divide that into your contribution margin per unit of $35, which is the difference between the 105 selling price that you would like to get minus the variable cost per unit at the most likely scenario. So here you run the numbers and you find out that your break-even point in units is now 686 units. All right, moving on, let's talk about some other applications. You can figure out your margin of safety, and what that is the amount over which your sales will exceed the break-even point. So you figure out what your expected sales are going to be and subtract your break-even sales, and then your denominator is going to be your expected sales. So in this case, the company thinks that they can sell 100,000. You subtract your break-even sales of 80,000. So 20,000 divided into 100,000 is 20% margin of safety. In pure dollars, It simply means that they have $20,000 excess that before they start to show a loss or break even, and then after that show a loss. Now you can use these contribution margin income statements to forecast sales or income. So it just kind of depends on which way you go with this, whether or not you want to find sales or income. So here, this is an example of Rydell. They think that they expect to sell 1,500 units in January. And the question is, what is the amount of income if this sales level is achieved? And so we can compute our dollar sales. Well, here it's 1,500 times $100 sales per unit, so 150,000. You can figure out your variable costs. That's 1,500 units at $70 each, so that's 105. Contribution margin per unit, or overall, is 45,000, which is 1,500 units at 30 each. Contribution margin per unit. Your fixed costs are still 24,000, so your income pre-tax is $21,000, and then you could take that and calculate an after-tax contribution margin income statement as well, which is simply adding income tax at 25% down there times $21,000 pre-tax income. So net income after tax is the difference of 21,000 and 5,250, or 15,750. All right, so if you know your fixed cost and you know your contribution margin ratio, you can figure out the dollar sales that you need to have at a particular target income. And so here, let's say we want a target income of $12,000. Your numerator is going to be your fixed cost plus the target income, and your denominator is going to be your contribution margin ratio of 0.30. And so here you're going to need dollar sales in order to achieve your target income of $120,000. You can figure out the number of units simply by taking the same fixed cost plus target income and dividing into your contribution margin per unit, in this case $30. And so unit sales at target income is 1,200 units. So this just shows you what we just completed. All right, so next we want to talk about evaluating strategies. Here, you've got a situation where, in this example, what they're doing is, it says that Rydell is considering buying a new machine that would increase monthly fixed cost from $24,000 to $30,000. So that's why you see 30,000 there in that example, and would decrease variable costs by $10 per unit, which means that variable costs will go from $70 per unit down to $60 per unit, which means that contribution margin per unit will go to $40 per unit. So it'll increase by $10. So the question, well, just completing the scenario, Rydell's break-even dollars is currently 80,000. How would the new machine affect Rydell's break-even point in dollars? And then it says if Rydell maintains its selling price of $100 per unit, its contribution margin will increase to $40, like I said, computed at sales price of $100 per unit minus the new variable cost of $60 per unit. With this new machine, the revised contribution margin per unit is 40%. Rydell's revised break-even point in dollars is 30,000 fixed cost divided into 0.40, your new revised contribution margin ratio. So $75,000. All right, next thing you want to do is look at how you can compute and determine a sales mix for multiple products in a company. And so here you have to modify your CVP formula, and the unit contribution margin is replaced with the contribution margin for a composite unit of all the products. A composite unit is composed of specific numbers of each product in proportion to the product's sales mix. The sales mix is the ratio of the volumes of the various products. And so the resulting break-even formula for composite unit sales is the break-even point in composite units, which is fixed costs as your numerator and the contribution margin per composite unit as your denominator. So here we have an example. Hair Today offers 3 cuts as shown below. Annual fixed costs are $192,000. Says compute the break-even point in composite units and in number of units for each haircut at the given sales mix. All right, so here we go. So you've got here, you've got a 4-2-1 sales mix. And so 4 units of basic times the $20 per unit means it's got a selling price per composite unit of 80. And then for the Ultra, it's going to be 32 times 2 and budget of 16 times 1. And then your variable costs per unit are going to be the 4 by 13 of the basic and 18 times 2 of the Ultra and 8 times 1 of the budget. So that's what that looks like. There's your selling price slash cut for each. The total selling price per composite unit is the sum of all 3 of those, the selling price per cut. So 80 plus 64 plus 16 equals 160. And then your total variable cost per composite unit is simply the sum of the selling price per cut of the basic of 52 variable cost times sales mix ratio of 4, so that equals 52. Ultra is 36, and the budget is 8, so you add those up. That's total variable cost per composite unit of 96. And so you take your selling price per composite unit of 160, you subtract the variable cost per composite unit of 96, and what you come up with is a contribution margin per composite unit of $64. Now, next you're going to take that $64 and you're going to divide the fixed costs of $192,000 in this example into your cost per composite unit, or your contribution margin per composite unit of $64. And that's going to be your break-even point in composite units. And you're simply going to disperse these out at 3,000 composite units times the ratio of 4, 2, and 1 for each cut. And so here we show that. And so you take your composite units and multiply it by the sales mix of 4 for the basic cut. That gives you 12,000 haircuts. Ultra is 2 times the 3,000 composite cuts equals 6,000, and budget is 1 times 3,000 is 3,000. So bottom line is your mix of haircuts at those levels of sales mix is your break-even point. And you can confirm that that's true by you take 12,000 of basics at $7 cost, what you charge for it equals 84,000. Ultra 6,000 cuts times 14 is 84,000, and budget 3,000 times 8 equals 24,000. You sum those up, you come up with total contribution margin of 192,000, and that equals your fixed costs. Therefore, you're at break even on your net income of 0. So CVP analysis relies on several assumptions. First, that costs can be classified as either variable or fixed. Costs are linear within a relevant range. All units produced are actually sold, and that the sales mix is constant. All right, so that's it for Chapter 18. I'll put this lecture out as well, and there is an assignment out there as well.